Okay. So today I'm going to start about the transformations part. Okay. Which is very easy, I can say. Uh, and tomorrow we'll try to understand about the action so that we can complete the. And one more day we have to cover actually the pair RDDs. So that won't take much time actually. Hardly like one hour, 1.5 hour. Like within 3 classes we'll complete this. 3 to 4 classes we'll complete this RDD part. Because I don't want to spend much time on the unimportant topic. Okay, but some core concepts are there, guys. Please try to understand. So do not ignore these classes. Try to grab the concept behind that one. Okay, so don't ignore it completely, but don't practice it. Practice is not required. Okay, yeah. So you guys know the like the meaning of these commands, right? So find Spark, PySpark, Spark context, Spark context is not required. Spark session is okay. So because Spark context is a part of the Spark session, that we'll talk later. Find Spark.init, Spark equal to Spark session dot builder. I mean, I told you already all these things in the other class. Okay. Now, what I wanted to do is let's get started with the Spark core. I can say the core actually we have to understand about the Spark transformations. I told you already there are two things are there in the Spark RDDs. One is transformation, second one is actions actually. Okay. I'm going to discuss about what is transformation, what is action. Okay. Now these are all the transformations actually. And these are all the these are all the transformations, these are all the actions, I can say. Mostly I'll try to cover all the transformations and all the actions. Mostly I'll try to cover. Okay. And these are all the pair RDDs, I can say. These are also very easy one. We apply these transformations on top of the pair key value pairs, I can say. Okay. Now, before we get into the transformations, actually, we need to understand one core concept here, that is lazy evaluation. Okay, this is very important entry question actually, and the same concept is applicable to the data frames as well. Okay. So what I will do is I'll just try to create an RDD here first of all before I get into that one. The RDD creation I've already told you there are three different ways are there actually to create an RDD. So by using this parallelize method we can create an RDD, or by using sc.text file command also we can create an RDD, or by creating another RDD also we can create an RDD. Okay. Okay, so first let's try to use this particular one. Votes RDD I'll try to create here. Okay, so copy this one. I'll just try to paste it here. Okay, so votes RDD equal to, I told you what is SC. SC is nothing but a Spark context. All these RDD commands are belongs to Spark context only. So if at all if you want to create RDD, this is mandatory actually. That is the reason why I'm creating an object called SC. On top of that SC only, I'm trying to use this object method actually. Okay, parallelize of parallelize actually method will take a list as input. So I think okay. So instead of this one, what I will do is I'll just try to take numbers here. You can take RDD1 also here. Variable, you can take anything here. Go on mute, please. Okay. Thank you. So here, if at all, if okay, so parallels will take range also as an input actually. So range of 1 comma 10 I'm taking here. So range of 1 comma 10, the function meaning you know, right? It will start actually from the number 1 and end -1 up to 9 it will take. Okay, let me try to create it this object here. Yeah, I created that. Okay, so I don't know whether backend it has created RDD object or not. How do we know whether it is creating really a RDD object or not? Come on, help me. Print off. Hmm. You guys
Type of
know the type of object you'll come to know with which command? Type of
RTD1.
RDD1. You guys already understood it in this one, right? Python, right? Same thing, same concept only. So see here, backend what it is creating. It could have created directly PySpark.RDD. I don't know why it has created actually directly pipeline RDD. Okay, we'll try to understand it a bit later. So my understanding is actually it creates actually normal RDD, PySpark.RDD. Okay, maybe we change the version, maybe because of that. Maybe in the latest version, they are creating directly the pipeline RDD. Okay, so, but as per my understanding, First time when you create an RDD, it actually creates a PySpark.rdd.rdd. And next RDD onwards, it is going to create actually pipeline RDD, which they are interconnected actually, because they are interconnected. Next RDD. Okay, anyway, we will talk about that one bit later. So what I wanted to tell you is, with this command, I was able to create actually an RDD. Now I'm confirming that it has created PySpark RDD in the backend. PySpark is actually a, I can say, package or submodule. In that one, RDD is a module. From that, it has created actually object is pipeline RDD. Okay. Shiva, how do we see the data from this one, RDD one? How do we see the data from this one? Okay, okay. Let me try to do one more thing here before I go ahead and see the data from this one. Okay, so I wanted to create an RDD2 actually. I wanted to create an RDDT. Guys, you can execute the commands in any number of cells here. Okay, so once you create an RDD, that RDD scope will be continued to the next cell as well. The scope of these variables or these commands is this entire session, I can say. Okay, do not think that, okay, whatever the variable I'm creating in this cell, the scope will not be carry forward or scope will not be present in the next cell. Don't think in that way. Okay, now what I'm trying to do is RDD2 I'm trying to do here. Okay, so for these numbers actually, I wanted to multiply with the 2. That's my requirement actually. So for that, what we will do is RDD1 dot. So if at all, if you want to do operation on each element, what command or what function we have in Python? Come on, this is the time to recollect the Python functions. Exactly. Even in PySpark also, we have map function or map method here. Okay. So there, map function or map method will take the collection as input. But in PySpark, always you need to do actually RDD1 dot map of we need to write. On top, see, every time you create, you write this command like this, it is going to create an object in the backend. On top of object only, we have to write all these things. Okay. Now I wanted to multiply all these numbers with 2. So for that, we have to write actually lambda function. See, you guys know map can take one more function as an input, right? You guys know that one,
Yeah.
right?
Yes.
Yeah. So same thing I'm trying to do here. Okay. So lambda x colon I'm taking here. Since I'm trying to multiply with 2, so x star 2. Oh, sorry, star, right? Uh, sorry, one second. Yeah, star 2. Like this I'm writing here. Can I take like this? Can I take like this?
Yes,
Okay.
sure.
Okay. Okay. So in one more cell, what I'll do is I'll just try to create one more RDD. Okay. RDD3 equal to, I wanted to filter out actually the numbers which are greater than 5 from this result. That's my requirement. So for that, tell me, can you guys guess it actually? Which, oh, sorry. Where is the transformation list here? So which transformations will help us actually for this requirement? I wanted to check which numbers are greater than 5.
Filter.
Yeah,
Filter.
exactly. Okay. So what I will do is I'll just try to use here filter operation, filter transformation, I can say. So on top of what? RDD2
RDD
dot
2.
filter. Okay. Of. So again, we need to write the lambda function. See, that is the reason why I explained lambda functions are very important. So lambda functions exclusively we use in Spark actually. They're not important in Python, but they're very important in Spark. That is the reason why I explained that one. Okay, so for that one, what I will do is lambda. I'll tell you the syntaxes also are the notations also for these commands, guys. Don't worry. For now, I'm just trying to explain the concept, one core concept actually. So for that, so x colon x greater than 5. This is what I'm taking here. This is going to create another RDD. Okay, now on top of, see what I'm trying to, first I'm creating actually one RDD. On top of that one, I'm trying to do some transformation. On top of that one, I'm performing one more transformation. Now I wanted to, okay, okay. So before that one, So I just wanted to show you, this is the Spark UI actually. When I say UI, you can track the executions in this particular UI. Spark runs on with this port 4041. Since I installed it in my localhost colon 4040, it will take. Sometimes 8080 port also it will take, I guess. Now it is taking actually 4041 port here. So currently, do we have any executions in your Spark? So far, to be frank, from yesterday, I did not execute anything. Okay. Do you see anything here? Do you see any
No.
executions here? No, right? No. Okay. So let me try to execute this one. Let me try to execute this one. Do you see anything here? See, in the jobs, actually, if something got executed real in the backend, it would have shown here, definitely. Okay, nothing is appearing here. Okay, now I'm trying to execute this one also. Something is wrong here. Lambda spelling. Okay, guys. Ah, yeah. Now let me execute this one also. So did it execute anything in the backend? No, I don't think so. Now what I'll do is RDD3 dot collect. This is what I'm going to use. I'll tell you what is the meaning of that collect. Okay, so let me print them. So for that, print of RDD3 dot collect I'm taking here. Okay, let me execute this one and see what is happening here. And it will display the output here. Now it is executing, you see here. Now see what are the numbers are there actually. First I took the number 1 to 9 and I multiplied that one with 2 and I'm trying to filter greater than 5 numbers and I'm trying to display that here. For displaying the result in RDDs, we have to use actually collect command. For now, you understand it is a command. Now these are the numbers I got. Output is correct.
Yeah.
Output is correct. Yeah, correct. Now you go and see here. Refresh it. See, something got executed now. After which command it got? We got that
Collect.
collect. Now I'll tell you the core concept here. Okay. So understand it carefully. Same concept is applicable for the data frames as well, guys. Data frame backend, it will try to execute RDDs only. That is the reason I'm trying to explain all these things. Okay. See, guys, understand one thing here. When you create an RDD, when you try, okay, let me take that one again. Yeah. So once you create an RDD, once you do transformation on top of that one, it is going to create backend one more RDD. When you perform transformation on top of this RDD, it will, let's say, consider the transformation, we are calling it as a T1. Okay. So the output object is actually, it is going to create RDD only. RDD, if you perform transformation on RDD on top of RDD, the resultant object is also RDD. Okay. Now, once you perform one more transformation on this RDD, again, it is going to create RDD only. Okay. Again, it is going to create an RDD. Once you create one more transformation on top of this RDD, let's say transformation, we are calling it as a T3. See, map, okay, flat map, filter, all those things we call it as a transformations only. Okay, now, once you perform that series of transformations, somewhere at some point you have to see the data, right? So for that, what you have to do is you have to perform the action on top of the RDD. Okay, once you perform action, the actual execution will get started. That is the reason why in our case, actually, in our case, once you execute that collect command, collect is an action actually in RDDs. Collect is an action. Okay. So that is the reason why it got executed, something got executed in the backend. What do you mean by this one? What do you understand from this one, Shiva? Some link, we got some link here and it is showing here 8 by 8. That's it. You know, what is the meaning of that one? What is this 8 by 8? Backend, it has created 8 stages or 8 tasks, I can say. So why it has created by default 8 tasks here? Why it has created by default 8 tasks? because let me show you one thing here. If I go here performance, see how many logical processes are there in my system.
8.
That is the reason why by default it is dividing into 8 partitions. One partition is equivalent to one task. All the 8 partitions are all the 8 tasks are executing parallelly here. If you want, I can show you that one. See, all these are parallel process. This is what I was telling you. This is task ID. Task ID 0, 1, 2, 3. How many tasks are created here? 8 tasks. Who created that one? Driver created that actually. Executor ID is nothing but who is executing that one. So since my Spark is actually standalone Spark, I don't have executors actually. I don't have separate executors. My driver itself act as a driver and as well as executor. Okay, that is the reason why executor ID everywhere you got it as a driver here. And who is that driver actually? My system. This is my system actually. Okay. And at what time they launched? All the tasks are launched at what time actually? At the same point of time. You see here the timing here. And how all got completed within 6 seconds. GC time is nothing but garbage collection. So this way you have to see actually. So how long it took actually? 6 seconds it took total. Total 6 seconds it took. Okay. So in this way, you need to understand the logs and other things, execution guys, actually. Now see, this is what we call it as a DAG, DAG, direct acyclic graph. It shows the graph of RDD operations. In this stage, RDD inside each one is a stage can run multiple operations. Example, two map functions, if they can be pipelined. I'll tell you the meaning of that one. I'll tell you the meaning of that one. See, in this case, what has happened is this is transformation, one transformation. This is one transformation. Together, it is creating creating backend. It is creating as a stage. That stage is nothing but this one. Okay, and after that, immediately, what did I do? I performed action on top of it. That is the reason why all those things actually executing here only. Now the correct operation is happening here. This is one stage. This is for collector. I'll show you like in depth, like once we get into the other topics.
Okay.
Okay. Now, did you get it here? Now we have to understand the conclusion points here. Remember here. Once you perform the transformation on top of RDD, is create the backend object is again it is creating RDD. Again transformation RDD. Again transformation RDD. Finally, once you perform the action on top of RDD, the actual execution will get started. Actual execution got started here. See, until you call the action, nothing is getting executed, right? That is what we call it as a lazy evolution. Spark always follows the lazy evolution. Okay, the meaning of lazy evolution is until you call the action, the transformations will not get loaded or transformations will not get executed in the backend. So backend, what it does do, then what it does Siva here, but when you try to execute something here, it is getting executed. But what it does in the backend actually, it is going to create actually a lineage graph in the backend. The link between these operations it is going to create. Okay, so since I'm telling once you create an RDD, perform the transformation on top of RDD, it is creating one more RDD. So just to prove that one, I'm just trying to execute this one here. See, it is creating a pipeline RDD or not. Now, map is a transformation. I'll tell you here, map, where is that map here? Map is a transformation. This is first transformation in Spark. Map is a transformation. This transformation I performed on top of this object actually, RDD. What is the resultant we got here? What is the result we got? RDD only. Okay, until you call the action, nothing will get executed in the backend. Once you call the action, the lineage it is going to create. So till that time, it is going to create a lineage. Lineage okay, RDD1 is actually RDD2 is actually deriving from RDD1. So RDD3 is actually deriving from RDD2. Okay, I have to link them actually. In that way, it is going to create an lineage graph. That's what we call it as a DAG. Okay, once you perform action on top of it, now RDD3, what is there? Okay, it is filtering. Now RDD3, like depending on RDD2. RDD2 is depending on RDD1. What is there in RDD? What this is the final RDD. What RDD1 is doing actually reading the data from sequence, from the range or from the sequence. Now the execution will start from in this direction now. Once you collect actually, the in order to create a link, it will go in a backward direction like this. The execution will start like this, forward direction. Even in data frames also, concept is same. Clear? Are we good till this?
Can you run that RD print command for RD2 as well? Print RD2 collect.
Okay, you want me to? Okay, okay, yeah, we can do that one. That means you're collecting the data here itself.
Yeah.
Okay. So RDD2 dot collector. Now what happens here? Oh, sorry, it is printing and it is we need to write the print command, guys. Sorry.
Yeah, print.
Print of this one. Execute this. Where is the printer? Now it is see displaying. I did not do anything. It took some time to get that.
Shiva, can you go to the Spark job now? Now two jobs will be get created.
Definitely.
Mhm.
Definitely. So
Yeah,
if I go here, jobs, see how many times it got executed? 3 times. This is the latest one actually. So if you click on this one, see 8 jobs got created. It is trying to use all the parallel threads here.
Yeah. Mhm.
Okay. Any other question here? So what my conclusion point here is, where is this? This is the one. Okay. So series of transformations finished by action. Finished by an action. Okay. Transformations are planned and optimized, but not made. This is what I was telling. Transformations are planned. Backend it is going to create a plan. That's it. And they're optimized by Spark engine, but not made. That means it doesn't read any data once you create an RDD2. Okay, see, the moment you create RDD1, RDD1 equal to SC parallels of range of 1 to 10. Backend really it will not read the data from the range function. It doesn't read actually because you're not performing any action on top of that one, right? Actual execution will not happen here. Actual execution will happen here. Okay, that is what I was trying to say. So lazy evaluation, action starts all process. Action actually starts the process, original process. Okay. Hmm. You can create actually on top of RDD2, you can create an RDD for on top of that one. If you perform transformation, one more RDD will get created. On top of RDD2, if you create one more transformation, RDD5 will be created. And on top of these two, let's say I'm trying to join these two RDDs, you'll get RDD resultant RDD like this. See, any transformation you perform on RDD, it is going to create one more RDD. That's it. Okay. So this is what I was telling you. RDDs, when you try to perform, when you perform transformation, it is going to create a RDD only. And once you create once you perform action on top of that one, then the output you will get, actual output you will get actually. Okay. So same thing I'm just trying to represent here. So create an RDD here. and try to perform transformations on top of them. Actually, it is going to create a lineage completely. Okay, and once you perform action, the result you're going to get. Okay, if you want to understand more, you can understand like this also. Let's say I'm trying to read the data from one of the database. I'm trying to read the data from other database. Reading the data from other data. I'm applying map on top of it. Map on top of it. I'm unioning these two results. Again, it is going to create what? Union is also transformation actually. And I'm reading the data from this one, right? I'm performing reduce here. It's an action again. Okay, so on top of that one, I'm trying to use match. And on top of that one, I'm trying to perform group by. On top of that one, I'm trying to write the data to sync some more database, another database, I can say. So these are all series of actions, I can say, series of transformations, I can say. It is going to create graph like this in the backend. Okay. Clear?
Yes,
Hmm. So job execution will happen like this case. Once you create RDDs, actually, it is going to create a DAG in the backend like this. Okay, first it will divide that into partitions, different partitions. These are all partitions, I can say. Who is going to do that one? DAG scheduler. DAG scheduler is nothing but DAG, I've told you, right? So that is also one of the, I can say, master node it can perform. So that is also one of the program I can say in the master node. That master node will divide that into partitions, and then it will decide whom to assign this particular partition in the now this task will be given to cluster manager. Cluster manager is nothing but again it's a separate program. Okay, so these partitions will be handed over to like a cluster manager. Hey, cluster manager, I have so and so partitions with me, like can you assign that work to the executors? Then cluster manager will go and check actually who is free, who is busy, who can execute the task. So then it will reply back to the master saying that, oh, hey, these people are free, they can take up the work. Then master will go and assign the work to these executors. This is the life cycle, I can say. Okay. See, the communication is always bidirectional here. Okay. This is what I was telling you, same thing. Okay. Transformation, do transformation, perform action, will get output. Hmm. Okay. One more thing you need to understand, guys, here. In the transformations also, there are two types of transformations are there. One is narrow transformations. Second one is wide transformations. This is very important interview question as well. Okay. So what is narrow transformation? What is wide transformation? Okay. Now let's try to understand with the map concept only here. Okay. You guys know. Let's say I have these many partitions in my master node. I can say in my cluster. I can say partition 1, 2, 3, 4. What I'm trying to do is here 10 elements are there, 10 elements are there, 10 elements are there, 10 elements are there. In the map operation, I'm trying to multiply each number with the 2. Okay, that's my requirement actually. So what it does is actually, what it does, what map does actually, first of all, tell me. What map does?
Iterate each element.
Iterate each element and perform that
Action.
that function, right?
Yes.
Whatever the function you're writing, right? Now tell me, 1, 2, 3, 4 are there here. 5, 6, 7, 8 are there here. 9, 10, 11, 12 are there here. 13, 14, 15, 16 are there here. Okay, 4 numbers are there. What map does actually? It will take the numbers from this partition and multiply those numbers with 2 and try to give the output. Correct? Same thing will happen here, other partitions as well. Okay, now all these results actually will be handed over to the master again, of course. Okay, now tell me, do we need any shuffling between these partitions or between these executors? Do we need any shuffling here? Executors, do they need to exchange the data?
Not
Does
required.
this partition need to understand actually what is there inside this partition?
There is no dependency, right? Not
There is no
required.
dependency, right? That means one-to-one like operation will happen here. One-to-one mapping will happen here. Now, what I will do is here, same thing. Let's say, um, uh, I've asked you to uh, group the data based on country or based on department number. Okay. So let's say I have a salary column and the department number column as well. My final output, my final goal should be department wise total salary. That's my goal. Okay. Let's say 10, 20, 30, 40, all the departments are equally distributed among all the partitions. 10, 20, 30, 40 departments are there here also. 10, 20, 30, 40 are also there here also. Or only 10, 20 are there here. 10, 30 is there here. 30, 40 is there here. 40, 50 is there here. But definitely there is a overlapping here. Okay, now when you try to do that one, when you try to do group by sum of salary, group by department number, what will happen in the backend? All the 10th department salaries should come into one partition, right? All the 20th department salaries should come into one partition, right? All the 30th department number salary should come into one partition, right? All the 40th department should come into one partition, right? Then only it can perform the sum operation, right?
Yes.
Okay, that means the executors or partitions or executors need to coordinate each other or not? Need to exchange the data between them or not? Or among them or not? See, this executor has actually 10th department data and 20th department data. This executor 10th and 10 and 30. Now these two has to talk actually, hey, you have 10th department, right? Give it to me that. I have to do like some of that salary. This executor will go and ask, do you have that 20 or not? If it is there, it will hand over it to this one. That means the data is shuffling between the executors or not.
Mm.
Data shuffling is happening or not? See, if the transformation requires a shuffling operation, then we call them as a Y transformations. Example for this one is group by or join. Example for this one is map. Did you get my point? Clear?
Yeah.
Let me erase this one just a second. The best example for narrow transformation is map. The best example for this one is group by, key by, and this one, what did I tell you? Join. All those things are actually Y transformations. So there are two types of transformations. If the transformation involves shuffling, then we call it as a Y transformation. If the transformation does not involve in any of the shuffling, then we call it as a narrow transformation. Okay, simple. This is one of the interview question, guys. It was very famous interview question in 2019-20 time. Nowadays also still they're asking. Okay. Okay, let's get into the practical part now. Where is this one? The execution part. This is the example I was talking. Map, filter, union, join, all these are narrow transformation. Oh, join is also narrow only. It doesn't do any shuffling. Join with inputs co-partitioned. Okay, so join with inputs not co-partition. With join comes at a narrow and as well as wide as well. Okay, group by key is the best example. If you get confusion with the join, the best example group by or group by key. You can tell that happily in the interview. Okay, so simple pictorial way I can tell say like this. Map is one-to-one, partition to partition. Wide transformation, it has to exchange the data actually. But shuffling will happen between the executors. Okay. Now let's move on and try to understand one by one transformation. Okay. Huh. The first one I've already discussed. I think map. I think filter also I've discussed, right? Do we need to discuss more here? Is there any other thing to discuss here? Map other than this? See, okay. If you don't know what this map does, what this filter does, you don't need to follow any third party website. Directly, we have Spark website actually. Oh, where is that? Okay. Spark website or Databricks website. You can follow anything. Both are same only. Okay. Both will give the same information, same content. No difference at all. Okay. Let's say all the RDDs they mentioned here. They see all the RDDs comes under Spark core. Spark core. Okay. So whatever the RDD that you wanted to know, simply you try to search it here based on alphabetical order. Just click on this one. You will get the syntax here, and you'll get they'll give you some explanation about that one, some theory about that one, and you need to understand and start using that one in real time. That's it. This is what I do in real time. Okay, we read the CSV files actually, spark.read.csv. Sometimes we forget the options, what options are there in the CSV file while reading it. Then I'll simply open the documentation and I'll try to check all the like properties in the CSV. Then I will try to use that one. Okay, clear. So this is clearly saying RDD dot. Always we have to use this map operation or map transformation on top of RDD object only. RDD dot map actually takes the function as an input. That is the reason they called it as a F function as an input. Preserving partition is an optional one actually. Okay, that means you wanted to keep the same number of partitions, or you wanted to create more number of partitions. You wanted to change that one. That we can give. So preserve partition by default it is false. What is the output of that one? If you see any symbol like this is the output actually. What is that output? You'll get a PySpark RDD. You'll get actually. See, I told you right first time when you use that one, it is going to create actually spark.rdd.rdd, right? That's an RDD object. Okay.
Shiva, what is T? T is a transformation, right?
Type of object, I can say.
Type of object.
Mm. Mm. So you don't need to worry about the T and U. Okay. Everyone clear? Huh. Now let me start executing the things here. Okay, you guys know already I've executed here. So it is displaying as it is. See what it does is actually it will take one by one element from the RDD and it will perform this. It will apply this function on top of each element. That's it. Map is one to one. That's it. Element by element, one by one it will take. Simply apply that function. So we have taken actually 1 to 9 numbers and I'm multiplying each number with the 2 here. 2, 4, 6, 8, 10. Simply multiplied here. That's it. Okay. So I'm just removing this correct here. If you want to see the type of object here, you can see that here. Now, after that, filter also we understood right here. Now, one by one, quickly we'll execute. Filter, what filter does, filter will actually filters or it indirectly it is a where condition in your SQL part. Okay. So in RDDs we have only filter, but in data frames actually we have where also. Where and filter both are same only. Okay. Now we'll try to understand here what filter does actually. This filter also will take the one more function as an input. That is the reason why filter also we call it as a higher order function. Higher order function. So this takes actually one more function as an input, and you have to give that condition here. So x greater than 5. It takes the one by one number from the RDD and it applies this function on top of it. Okay, now we understood this one also. Now what is that next one? Map partitions, map with index, we'll see later. Okay. So next one I wanted to explain here is sort by, group by. If you want, we can understand now itself. So sort by is actually, if at all, if you want to sort the elements based on ascending order, based on some value or based on something, then you can use this sort by, group by. Okay. So let me try to execute that one here. Okay. If you don't know the syntax and how to use that one, the usage part, let's say I forgot the syntax part. Okay. Now what you have to do is we have to go on where is that sort by? Here on the right, sort by, sort by, sort by, sort. Yeah, sort by. This is the one. See, this is the syntax actually. So sort by of what it does is it takes the function actually based on what you wanted to sort the data. That function it takes an input. Ascending order. Okay, it's a Boolean value actually. The data type is Boolean. You need to mention true or false here. If you mention true, by default it takes actually ascending order. Ascending equal to true means it will arrange the data based on ascending order. Okay. If you make it false, then it will sort the data in descending order. Okay. Number of partitions, if at all, if you want to control, you can control that one here also. So result is actually RDD with the transformed RDD, I can say. Okay. So again, this sort by also takes the function as an input. Okay. Let me tell you one. If you want, I can take good example here. Okay. I have an example here. Let me show you that one here. Where is this sort by flat map? I can tell you. Filter union subtract sort by. Yeah, this is the one. So R1 dot sort by lambda of if at all if you want to sort them in an ascending order, I'm simply using here ascending equal to true here. That's it. Okay. So okay. So let me move on to the next one. That is flat map. This is what we need to understand next. Actually, map we understood. Now we need to understand about the flat map. Okay, if you want to understand more about the map, right? I have an example here. I can show you here. So what this does actually, names equal to Alice, Bob, Charlie have taken. SC dot parallel is what it does. It is going to create what? RDD. Okay. Now what I'm doing is name RDD dot map of lambda, name it takes as an input here, and it will try to create a pair key, like a tuple actually. It is going to create a tuple. So name comma length of name. Name comma length of name is nothing but how many characters are there in that particular one. That it is good. See, if you don't understand these tuple concepts and all in the Python, you don't understand the functionality here. That is the reason why I explained all these tuple concept and list concept and the map functionality and everything there. Okay, now see how it is going to give the output here. I'm executing this. It is executing in the backend. Now it is going to display the output as well. See, Alice comma 5, Bob comma 3, Charlie comma 7. This is my output. Okay. Confusing? Anything confusing here?
Nothing, sir.
Hmm.
In backend, how many partitions and how many tasks were created?
You can see that actually here. Now, if I click on jobs, what is the most recent one actually? This is the one, right? 3 job ID 0, 1, 2, 3. Yeah, it will keep increasing actually. Now, if I click on this one, see 8 partitions it has created. Okay. Now if I click on this one, see, this is the one actually we got 8 partitions it has created. Everything got succeeded here. Yeah, by default it creates the, I mean, that based on the system configuration, guys. I'm not saying that default 8. Okay, based on the system configuration. I mentioned while creating the Spark session, I clearly mentioned use as many number of as cores in the backend. That is the reason it is using all the parallel threads.
So each partition is executing what?
Oh, yeah. Oh, since you asked that question, I'll tell you one more thing. Okay. So, Shiva, in which partition, what data is there? That's what your question, right? Next question, right? How do we know that one? How do we know that one? That's what your question, right?
Yeah.
Okay. Now let me execute this one again. Yeah. What I will do is, if you want to know the partitions, RDD1 dot, we have to use a function called glom. That's it. So this is going to create actually again RDD. On top of that one, we need to use collector. Okay, let me execute this one. See what is happening here. Glom dot collect actually will give you the partition information. Now see, I told you already it is going to create 8 partitions. Total 9 numbers are there. How it is distributing, you see here. In one partition we have 1, second partition we have 2, third partition 3, and so on. Last partition it is having 2 elements. I told you already, maximum it will try to distribute the data equally. Maximum it will try. But I cannot give any guarantee that it will distribute equally every time. Okay. From the first partition, this data got processed. From the second partition, this data got processed. From third partition, this one. Like that, last partition, data processed parallelly. All the partitions, all the tasks started parallelly. I've shown you that.
So you are saying sometime it won't utilize all the partitions, right?
Let's say you have only 5 here. You have only 5 here. Okay, now still what is happening here? It is going to create some empty partitions. Nothing to do with that one. That is not in my control. See here, this is empty partition, and this has 1. This has empty partition. This has 2 empty, like this. Okay, clear. So this is the command actually we have to use to understand the partitions. But real time we never ever use this one. Only this command we use in RDDs, not in data frames. We don't need to understand also how many partitions it is creating. That is purely depends on the how much volume of data you are uploading. Let's say you're uploading 1 GB of data. By default, without second thought, it will try to divide that 1 GB with 128 MB. You'll get almost 8 partitions, right? By default, you'll be able to see 8 partitions in the backend.
Shiva, based on the volume of the data, right? So
Mm-hmm.
how can it
That is what I
give
was telling you. Spark is not good for the small data.
yeah.
Okay, Spark is meant for like big data, not for small data.
Yeah, based on the volume of the data, right?
Yeah.
Sometimes we may need to spin up the cluster, right, and down also, right? Based if
Mm-hmm.
suddenly volume down based on the client data. So
That
how
is the
can
reason
we?
we have like this one is there, right? In Snowflake, we have minimum and maximum number of concept is there, right? In
Concept. Yeah,
cluster.
yeah.
Same way here also, we have minimum and maximum we can mention.
Yeah, we need to at that time, suppose if it is taking more than specified cluster, right? Suppose
Mm.
so volume of data coming, then we need to manually go and configure again
No, no, no,
to
no, no. In Databricks, especially, you don't need to do anything manually. See, in the standalone Spark, in the I can say 2017, 18, 19 time, we used to submit the jobs. We used to do Spark submit actually. Spark submit means that is also one of the application in the sense like that is also one of the command. We have to write our own whatever the logic that you wanted to write. You have to write it in a .py file or a .jar file, and you need to mention that configurations. How many cores you wanted to create? What is the memory that driver has to take? What is the memory that executor has to take? That you used to control. Nowadays everything got automated. You don't need to control all those things actually. Everything is automated here in the cloud. Manual intervention is reduced drastically in last 4 to 5 years. Got the point?
Yeah, sure. Because why I'm asking, because in one of my previous project, right, that guy, project mate, he worked in PySpark project. So I just asked if any of the program, then he shown one project there. What they are doing, they are doing some automated this one, like based on the volume of the data, they are spinning something. Uh, Cluster something like that actually. So
Mm-hmm. So
so automatically,
dynamic
yeah,
resource
automatically
allocation concept
system.
is there in Spark actually.
Uh,
Uh, Based on that, okay, Spark will automatically allocate the resources in the backend. Or
oh,
if at all, if you
okay.
want to control number of executors or the number of cores per executor or RAM size per executor, if you want to control that one, you can also control that. But in
Oh,
Databricks, we don't have such concept actually.
okay. Oh.
Okay, in traditional Spark, we used to have that.
Yeah,
I
I
agree.
think.
I completely agree
Mhm,
with that.
mhm. So if
Okay,
less volume of data tomorrow, then it will they will reduce automatically the number of
automatically, yes, yes.
yeah, based on that automated script.
Mm, correct. Okay. Next one is actually flat map. This one also we need to understand. Okay, so what I will do is I'll just try to execute this one. Okay. Um. oh. So this is my list actually. X equal to I've taken here two list objects actually here. That means list has two sublist as an elements actually here. Okay. So sc dot parallels of x I'm taking here. Okay. So flat map of lambda x colon x I'm taking here. Based on the output, you tell me what you're okay. So like what you're expecting the output here.
Altogether one list.
One list, huh? Why? Why is it so?
Because it will flat all map.
Oh,
So it will.
see the meaning of this one is it will flatten the elements. Okay, so that is what the meaning of this one. Let me execute this one and see what is happening here. Okay, see what is that output you got? One by one element it has taken from this list. It is simply flattening that. That is the meaning of flat map. That is the usage or functionality of the flat map. Okay, now tell me, this is one of the interview question. Now I don't know whether nowadays people are using asking or not. What is the difference between map and flat map? This is one of the important interview question again. What map does, what flat map does? Come on.
Map is to just iterate each element and do the
Hmm.
thing. Whereas a flat map just collecting all the elements together. If you want to like multiple are there, just you want to display as a single, then we will use as a flat map.
Okay, so this is one element, right? Actually, this is one element. This is another element, right?
Yes.
Okay, let me one to many. I can say here. Here one to one. Map is one to one. Flat map is one to many. Okay, in that way you can think. Okay, now let me tell you one more example here. Okay, I'm taking here. So same way, I'm just trying to copy paste here. So instead of this one, I'll simply take here Shiva single quotes I'm taking here. Okay, now tell me the output of this one. With this one, Python I'm taking here. Tell me the output of this. Come on, guess it. Even if you give
It
wrong
would be
answer, I don't
Shiva
mind it.
Python.
You will
Yeah,
come up
Shiva
with Python.
Python.
Shiva Python, huh?
Yeah.
How many
Shiva
of you say Shiva Python is the answer?
Two different
Karma
elements.
Python.
No, there
Shiva,
are no,
Karma, Python.
Python.
There are
no,
no?
no, Shiva, I guess it won't execute. It will get any error.
No, it will not throw any error. You'll get the output definitely.
Take
Now
exert.
tell me, you're forgetting one core concept actually. String core concept you're forgetting.
Yeah,
What is
that
that?
by dot.
See the output here. And at least based on the output, you tell me. What is
Yeah.
happening here?
Yeah.
Here
Each
it is
element.
by one. Each element.
Each character, why it is taking like this?
Because we have.
Shiva is actually a collection or not? It's a string, right? How string is actually stored in the backend? String is a collection, right?
Yeah.
Collection of object, collection of characters or not?
Mhm.
It is flattening that one also. Flattening that one, that's it. That is the reason we are getting each character here. Okay. So the main difference between the map and, okay, if I try to use the map here without this one, map. Okay, let me execute and see. Now see what is the output here. You'll get as it is Shiva Python here. You will not get anything. See? But when you write actually flat map here, see, one more thing you need to observe here. I'm writing here flat map, right? Now, if I execute this one, it will throw error. Why? What did you observe here? M should be capital, guys. Guys, remember, Spark always follows the camel case. What is camel case? First character of the first word is lowercase. Every other word first character is uppercase. In that method. Okay, it follows the camel case. So methods are case sensitive here. Remember that. Okay, now let me execute this one and see what is happening. Each character will get as an output here. Okay. So that is about flat map. We understood map, we understood flat map, we understood filter, we understood, yeah, I think only 3 we completed. So shall we continue or shall we stop here?
Stop.
Today is holiday, right?
We can.
Okay, let me stop here. Let me stop recording the session.